EPAWA Weather Consulting, headquartered in Worth Whitehall, Pennsylvania. This is Weather Weeklies, an informative video of the ins and outs of weather that affect you most in the EPAWA coverage area. The thoughts and opinions expressed in this video are those of the forecaster alone and may not reflect those of the staff of EPAWA Weather Consulting LLC as a whole, nor its constituents. Now, without further ado, here is meteorologist Bobby Martrich with Weather Weeklies.
Good Sunday morning to you. It is Weather Weeklies Sunday. I'm going to spend a lot of time today going over the upcoming pattern, of course, but I did want to start off today's video with a little explanation of that system that we just had. It had some intense banding just south of the I-78 corridor in both Pennsylvania and New Jersey. So we're going to discuss that a little bit today, and then I'm going to go into the long-range pattern and what made this flip around a little bit. Long-range outlook that I did on Friday kind of spread the bad news. If you follow me on Twitter, well, bad news if you're a snow lover anyway, but if you follow me on Twitter, I kind of outlined a little bit why this was. If you're a forum follower, you already knew this was happening as well. But on Friday's long-range outlook, I put out this long-range forecast that looks a lot different than it did just a week ago, okay? And there's reasons for that, of why that occurred, and why there were some indications that it was going to be extended for a very long period of time, and that's not going to happen, so we'll discuss that too. Here is what average annual snowfall is in the month of February and March. Some of these areas have already eclipsed what is normal in the month of February, so you are going to be above average in some areas. Not all these areas, but some of these areas will be above average in February, okay? And we're still an opportunity for something here, but going forward for the rest of the month here, but it's going to be a tight window, and I'll discuss that here today too. March, the numbers are about cut in half just across the entire region, except for interior areas up by Scranton, Wilkes-Barre, which can still get a decent amount of snow in March too, because it's colder there. So everything kind of favors more the interior for those things to happen here in the month of March. Here is year-to-date snowfall. We have one location within our major climate sites that are now blue, and that is Allentown. You are actually above average to this point in February. Okay, you should be at 22.5 right now. You're at 25.2. And what's crazy is everybody's going to say, well, we had that band hit that hit Allentown. Well, it didn't actually hit Allentown Airport. It was south of I-78 for the most part, or right at I-78 and south. The airport's up just north of 22. If you know the geography of the Lehigh Valley, that is up further north. And actually, now I'm in Whitehall Township, even further north than the airport by about 5 miles, and it was 4.5 inches. So 25.2 was including 5.7 from that system yesterday. Areas farther south, some of those areas got in the 12 to 14 inch range, which is really incredible. And that was not figuring in their seasonal totals here. Had Allentown got into that, we probably get to normal snowfall for the entire season, which is about 33.1 inches for an entire season. Don't know that we're going to get much more than this in some of these areas, but we get up in the Scranton Wilkes-Barre area, probably add a little bit to it, but everybody else is red because they're below average, slightly so, but below average nevertheless. You did make up some ground this week between two different systems, but not enough to put you above average like the Allentown area is. So what happened with that system? So we were dealing with mesoscale banding, and this is always a tricky thing, no matter what you look at. Okay, so there is, we did expect some banding in this storm to be in these areas right here where they have circled. From the mesoscale discussion from the Storm Prediction Center, this was put out on Saturday evening, right? As it was occurring, you had this band that started setting up right here, okay? Now, this band became very important because under that band, you have some intense lift, okay? So you have rapidly rising motion in the column, and this is near where the frontogenesis was. The frontogenesis was sitting right about here for this event, okay? And this band ended up on the northern periphery of that, kind of went like this, okay? I lost my size here. Let me try this again. So the frontogenesis was actually south of this. So we expected the heaviest snows to be generally in these areas where I'm circling here, okay? And then it ended up being on the northern periphery and just kept going like that, okay? And it ended up doing that in spite of any model that ran that evening, okay? So it was expected maybe a little bit out in these areas, and that's why we went higher in those areas for that snowfall. But what ends up happening under that band of rapidly rising motion is areas just south of it and just north of it has subsidence or sinking air. So what goes up must come down, right? Around the outside of that, there was some sinking air, which cut down in snow totals underneath the band, especially, and then initially north of that band. It did fill in later here, at least the northern part, and to some extent the southern part too, just not as much, okay? So that's how it started. Once you got later in the evening, it looked like this, and this now moved over the southern part of the Lehigh Valley, going back from Reading to the southern part of the Lehigh Valley through central New Jersey, and it just absolutely poured snow to the point where some areas in near the Hellertown area, which is just south of Bethlehem, Pennsylvania, they got about 5 inches of snow in an hour. So, I mean, it was coming down in these areas. This band sat here for 2 to 3 hours and didn't move. And I do have an image of what that looks like here. This is from Tumer Berg and his site, polarweather.com. And I'm just going to move this forward here so you can see what it did and the development of this band. So it started off near the Harrisburg area, extended back into northern Franklin County, went into southern Berks initially, right? And then as you move this forward, it started lifting off to the north, and it started clobbering areas that were, again, just right across the central part of Berks and the southern part of Lehigh Valley, and that extended it into northern New Jersey, or excuse me, parts of central New Jersey. But this was a 15-mile wide band. That is it. Areas to the north, not getting hardly any snow. Areas to the south, lighter snow. You had that subsidence above and below that band there, okay? So under that area of intense lift is where you had the heaviest snow, and you had some 2, 3, 4 inch an hour plus rates for a time while this was moving through, and it was shafting areas further north and south, okay? Now, north did fill in, okay? I'm not worried about the north part. It ended up being these parts just to the south of the band that ended up with like an inch or maybe 2 inches of snow, and really cut down because of that intense band and how intense it was when it was sitting over here. And I kind of just sat there. Look, it just sits there, right? So that's what ended up happening with this system, is this mesoscale banding feature set up. And this was a result of not convective instability, but which produces thunder snow, but this was a different process. This was conditional symmetric instability, okay? And what that is slantwise convection, okay? So instead of going vertical in a column, which would produce thunder snow because you get a charge separation and you can have lightning, right? This is not something that produces that. This is slantwise convection that just takes advantage of all the moisture in the column and just dumps it out, converts it to snow, and it's happened right through the dendritic growth zone. The reason why it was unforeseen, however, is if you look at the sounding, that this is for the sounding that ran at as it was happening. It finally picked up on the idea that there would be some CSI, and I was right in here, okay? There you can see the the conditional symmetric instability was right in the middle of this dendritic growth zone, or where the snow was born. So since you had that penetrating that layer there, it was able to take advantage of that moisture and turn it into a very heavy snow and rapidly rising motion as a result of that. However, the models did not pick up on this until it was actually happening. This model ran at 1 o'clock in the morning, and it was already happening at that point. So yeah, it said, okay, here it is. Before that, it didn't have anything like that. And this is a mesoscale model that is designed to pick up on this feature, and it simply missed it, okay? They all did. There's several mesoscale models we use, not just the NAM. We have the HRR. You can use the WRF, but it's not really designed. That's more of a research model. But there are some other ones that we can use too. Not one of them picked them up. Not one of them. So I can't sit here and put on a map an area, first, that it's going to happen, and second, where that placement of that line is going to be, which is only, at this point, it was only 15 miles wide. That's it. That's all it was. 15 miles wide. I can't put that on a map and expect it to be in a certain place at a certain time if no model is suggesting it, okay? And they did suggest it as was happening, but then it's like, no shit, okay? We see it's happening, duh. Now, thanks for telling me in advance so we can make a forecast. But even then, it would have been tough to forecast and pinpoint exactly where it was, except for me to put like a red circled area on a map and say, hey, this area has a chance to go over if banding takes place. If we see in advance, that's something we usually do on a snow map. Okay, we'll circle an area and say, this has potential in this area to go over within that circled zone. So we would have done something like this instead, and would have been like, if we were doing it right, we could see it in advance. We would have been like, this area here, we'll put a red circle around it. That could go over. And that would have been a different story, but no model had it for us to suggest that. So I look at the models that ran that evening. This is right before this. This is the 0Z run of the NAM that evening that suggested none of this. Okay, it had a little bit of enhancement rate around here. See that? It's a little higher there, but it's about 4 or 5 or 4 to 4.5 inches, something like that. Okay, it wasn't 12 to 14 inches. Okay, it totally missed that CSI, or the conditional symmetric instability, and therefore missed out on that band and the potential of what it could do. So I kind of equate this to a thunderstorm in a sense that, as far from a forecasting standpoint, I can tell you there's going to be thunderstorms or potential for thunderstorms on a certain day. I can't tell you if that your neighbor's tree that is annoying the shit out of you, that's 50 miles or 50 feet away, is going to get struck by lightning in a particular thunderstorm. I can't do that. That's impossible. Same thing with this. If you can't see it, if there's nothing that you can see at all on these soundings until it's too late, I can't sit there and draw that and put it on a map and tell you in a pinpoint location this is going to be there. Okay, it's just one of those things that as it evolves, you see it happening and then you adjust. So in fairness to the National Weather Service, they had winter weather advisories in a lot of these areas, expecting 1 to 4, 2 to 5, something like that, of snow. And then when the band was obvious that it was occurring and where it was, they upgraded to winter storm warnings because of that, because of this band and its presence. They could see it. It's just moving on the fly. It's part of nowcasting, and that's what they did. So they were able to do that in the middle of the night, upgraded to winter storm warnings, which was warranted, and those areas got hit. Now, I will say that in particular, in this image that I have for the radar as I move this forward, and again, great job here by Toomer Berg putting this together for the so we could visually see it. Now, I'm going to stop this when it right about... Oop, I was going to stop it. There we go. Okay. So Allentown City here in this point. I'm going to take Allentown City. This is right here. So the dot where the N in Allentown is, right about there is where Allentown City is, okay? The northern part of the city, and if you're familiar with the Allentown area, if you know where the Rose Bowl is, over on Sumner Avenue, measured 4.5 inches, okay? You go 10 blocks south of there to Hamilton Street in downtown Allentown, they measured 7.8. 10 blocks away, went from 4.5 to 7.8. You go another 12 blocks south of there to Mack Boulevard over by where it meets Emmaus Avenue, over in that area, 12.1. Or actually, it's over by that giant food store on Emmaus Avenue. I guess it's moving, but whatever, that shopping center, 12.1 inches. Okay, you're talking about a span of a very short distance there that went from 4.5 to 7.8 to 12.1, the further closer to the band you got. And there were many areas, some say between just north of Reading over through Macungie, Pennsylvania, over to Emmaus, over to Hellertown, and then through central New Jersey and parts of Hunterdon County, Somerset, Middlesex. They got anywhere from 10 to 14 inches of snow, which was pretty incredible. Pretty incredible amounts. I even saw a report here in Macungie. Somebody was saying it was like 15, but I'm not sure if that was accepted as accurate. But either way, you're under that band, you're getting it. If you're not, you're not, okay? And that's exactly how that happened. So I didn't want to spend too much time on that. I just wanted to talk about that a little bit so we understood what happened and how this is impossible to forecast. I don't care who you are. If you can't see it in advance, you can see it as it's happening. And as it's happening, the models did, in fact, adjust to this, and it did have the CSI right here, okay? And there it is. That's the conditional symmetric instability that led to that band and gave you the intense rates and why it occurred. Nothing you can do in advance to do that. You just have to adjust on the fly, and the National Weather Service did that very well, okay? So now let's talk about shift gears here, talk about the long-range pattern and why that was killed, because this is going to be an 0 for 2 thing here. We did expect that there were going to be some time spent into phase 8 here, where you have the colder pattern before it collapsed into the circle death. We did expect the collapse, but we expected a little bit more time spent in the phase 8 phase here, and it barely went in there for like a day, if that, not even a full day. So it didn't have the effects of phase 8 really realized before it since collapsed in the circle of death. So that is a big part of why that blocking that we expected to be in place for a very long time, from mid-February through mid-March, we expect that to be a very cold period and an active period because we'd have blocking set up. Well, the blocking did set up, but it's not going to maintain because this collapsed in the circle of death, and it was only in phase 8 for a very short time. So you're really getting phase 7 effects in reality in the circle of death, and there's even some indication that it might even go into the maritime continent for a little bit, which is a warmer phase, which would completely flip the script, and that's exactly what's going to happen. So started with a Mad-Angeline oscillation and the models failing to project this properly, and it went into the circle of death. So, and we were also looking at this a week ago and saying, well, this is plausible, and the reason it's plausible is if you take all of the El Niños and blend them together since 1876, the mean and the El Nino, the natural or prototypical El Nino paradigm for February looks like this. And this is what they were showing. You had blocking, you had ridging in the western U.S., cold underneath the block, and a very active pattern. So this is typical of that pattern. Okay, so this is gonna step away from what is typical and go a different direction, and it's because largely because this didn't fail. This failed here, and also because the Pacific is very uncooperative. Okay, we have a Pacific jet extension that's not playing nice this winter, and so this is the look that we have currently today. We do have the blocking in Greenland, cold underneath the block. You have ridging in here in the western United States. This is actually a pretty decent look, okay, but this was expected to stick around for a while, and because of those changes that I spoke about, the Pacific and the blocking not sticking in, this is going to go away. I put this in motion. Watch the blocking go away. And then watch the warmth start coming in. It'll be turning milder this week. You will have another cold shot come in right behind our system, or around the time the system comes in late week. That is a winter storm signal yet, temporarily. But then you have cold coming into Alaska and the western United States. Is going to keep us mild going into at least early March. Okay, so it's going to turn quite mild. It looks like very end of February, 50s, maybe even touching 60 in there. But I'm not looking at this being an extended pattern of cold anymore. And I did talk about this in the long-range outlook on Friday, the reasons why, when the written outlook, and then we also did something on Twitter where a couple days before that where I said this is not going to be turning out, when it was obvious it's not going to turn out exactly the way it was. You looked at this a week ago, it didn't look like this at all, okay? And these are things that change suddenly, just one little thing changing, like blocking not being established for a long period of time, and it just goes away and it flips the script, and this is exactly what happened. You can blame that on models, and again, I was looking at these models and giving them, we look at the observational data and then we look at the models and see if what they're showing makes sense. And it did make sense because, again, this is a normal, prototypical El Nino paradigm for February. Okay, this is not unexpected. This is what it's supposed to do. And since it was showing that, odds were that it would work out. But long range is always a probability-based thing. It is not deterministic. It's why we put a confidence scale on the charts that we put out. We put moderate, low for confidence in March on those outlooks, because there is some uncertainty. There are some risks. The longer you go out, the more risk there is. Okay, so we don't go high in those confidence values because we know things can change. Okay. This was never. I was convinced. I was convinced that this is going to end up happening. Okay, and it's not going to happen. So it is what it is. But that's what ended up happening in this case. And so the temperatures, as a result of that 500 millibar pattern changing that I just showed you, where the blocking goes away and then you get some milder come in. This is what it does to the temperatures. Okay, you get some temperatures that come in that are. I got the wrong image here. Darn it. Okay, just trust me that the next 2 weeks it's going to be changing. The Euro Weeklies is still showing here that once we get past that first week of March and go past, like, say, the 10th, you're going to have some blocking returning to Greenland and have some cooler shots exactly when we don't want it, which would be very tail end of winter. We're talking about just before the equinox and then beyond into early April, where you still have risks for cold. I don't know about snow so much, because at that point you're really fighting the sun angle at that point, and you'd have to have something come in at night. You'd have to have everything perfectly timed and tracked in order to produce snow. It has happened before, but it doesn't mean it's likely. It's probably less likely for that to occur. So looking at these periods last week, it looked like cold through the end of the month, maybe getting near average first week of March and then going right back, but it never went above average. This is last week's EPS run. Last week, okay, that went all the way through the end of March. You'll notice there's no warmth here, okay? These are 7-day intervals going through the end of the month, and then beginning of March is kind of near to slightly below average, and it just reloads and comes in as cold after that point. But now what it's doing is it has the warmth in early March, and then it has the cold coming in once you get close to the equinox and then going into early April. Is that really a realistic thing? Well, maybe, but I don't want to jump on that and say it's definitely going to be colder than average then too. A lot of that is doing that because of this is the same 100 members of the Euro extended ensemble, and it's showing the stratospheric warming taking place in this area right here. This is what would set up late March and early April to be colder, if this is correct, okay? And that's a big if, because these have been failed attempts for zonal wind reversals here recently, okay? They all suggested this would happen a little bit faster and sustain. It's not going to sustain. It's the second time in a row now where it had a projected complete zonal wind reversal at the 10 millibar level, and it failed. Okay, it only briefly dipped in there for less than 24 hours and then quickly recovered. Okay, so when it's showing this out in the long range, which is still showing another sudden stratospheric warming event and sustainable at that point, I don't buy it. Okay, I don't buy it, because we've had 2 consecutive failed attempts at this. It can happen, and if it does happen, you are going to get something like this, which is when nobody wants it, and it's going to turn colder relative to average. But this is relative to average at that time, which are now getting into the 50s. So you don't need a little bit more than slightly below average to do it, I think, unless you are in a far interior area across the far north. And this occurs at night. Okay, that's your best probability. Doesn't mean you can't get it elsewhere, but you got to really pull teeth in order for that to happen. So I don't think that once we get beyond this, the end of this week, which is our next winter storm signal that was listed, you really have much opportunity. You might have something for a thread the needle event, not impossible, but I think we can handle that on with the daily forecast videos. I don't want to sit here and string these videos along, looking ahead to the long range. It looks rather bleak, and just continuing for the sake of chasing ghosts. I'm not interested in doing that. Okay, if something pops back up, we might be able to run a special weather weeklies, to talk about it on a Sunday, that kind of thing. But I don't think as of right now, we're going to be continuing these beyond this week. Here is that winter storm signal. Cold front moves through on Thursday, and then the system follows it. That's the idea. This is only shown by the European model, and it's actually shown to be rain because the cold air doesn't catch up to it fast enough. But there's the signal, okay? This has been shown at different times to show some snow. If the snow of the northern stream can catch up to this system, it can certainly allow that to change over to snow. It could be a different outcome. So I want to keep an eye on this. I'm not going to write it off just yet. But I will say the GFS has absolutely nothing trailing, and so does the Canadian. Neither have them anything trailing, and this is what the GFS ensemble has for that period. Not very many chances for snow here with the 30 individual members. And as a matter of fact, there's only a couple, and it's mainly the interior areas. See that? Looks like parts of northeast PA, north central PA. There's a couple. That's about it. Some near the Europe-Pennsylvania border here, but I mean that's it. So it's not really thrilled in this idea of there being a winter storm at the end of this week either. So it is entirely possible that what we just had Friday night and Saturday, might be the last chance for most of you. Okay, and again, I don't know that we need to continue these videos longer because of that. But if something does change or pop up, and it certainly can, we can go back to a situation where the models are still blowing it, and maybe there will be blocking coming in a little bit earlier that was unforeseen or something like that. I don't see that, but we'll see. Here's what the GFS ensemble has for this is one that ran last night. So anything that happened up to here was actually the last storm this way. So that's already throwing this off. But going forward, a lot of these have very little. This is that period that we're talking about at the end of the week. There's a couple systems in there, a couple of those ensemble members or extended members that are suggesting we're going to have some snow out of that. This is at Lehigh Valley International Airport, by the way. You have a better chance that you would have something like that further north. But going forward, there's only a few that are really suggesting anything of merit. So I don't see this being a big thing. And the ensemble mean has come down significantly from last week as well. So I don't see this as a reason. And I'm not going to completely throw in the towel. Everybody's like, yeah, throw in the towel. We're done. We may be done, but there is an opportunity for something to thread the needle yet. And that's all you can really expect the rest of the way. And we can handle that, I think, in the daily forecast videos, unless something is actually physically presenting itself. You got to remember, next Sunday is already past the end of the week system. Even if that does turn into something, it'll be over by then. By the time I do a Weather Weeklies video, and then we're going to a mild period for the rest of February and at least the first week of March, if not the first 10 days. And then we'll see after that. Again, these the longer range models have been terrible this year, so they're projecting something cold, hoping that this is going to work out. Paint me skeptical, okay? Paint me skeptical. So we'll see. I don't see it happening, but there is a possibility that spring could start off a little colder than average. But it'll be relative to the time of year. It's not going to be, and maybe it wouldn't be in the 50s, it would be in the 40s instead. But it might not be cold enough at that point for snow, except if you're in the far interior areas. So in summary, what once looked like an extended colder pattern is not likely to happen with transient blocking that's happening now, and the MJO cycle not doing what it was supposed to. So Pacific pattern is going to be able to take over. We're going to turn mild here end of month and beginning of March. Still watching the late week storm signal, but we're not as thrilled with its prospects at the moment, as I described. We're watching stratospheric changes that could extend cooler temperatures in early spring, but that is a wild card. That is not a guarantee. Again, failed attempt after failed attempt for that zonal wind reversal to take place, and it just hasn't done it. So I don't really expect that to necessarily hold up, mid-March onward. We'll see. But if that does happen, it could mean early spring could be a little cooler than average than you would like. And then this may be the last weather weeklies of the season. We're going to see where we are next week and make that determination. But it was a long ride here. This is exactly why I don't do seasonal forecasts, because they are total BS, as you obviously can see. So when you see these next year coming out from different sources, take it with a big grain of salt. I mean, it looked like going into this winter, it looked like it was going to be a lot better. And I said that back in November. Look, it was going to be a lot better than certainly last year, but that wasn't going to be hard to do, right? So it was better than last year. We had more snow than last year, but it's still going to end up below average in many places. And, unless we get saved by some miracle storm here at this point, and it doesn't look that great. So when you're looking at these next year, just make sure you have that in the back of your mind, that seasonal forecasts are more for clicks and attention than anything else. We're going to stick to our long-range time lead, limited time lead for forecasting long range to 5 to 6 weeks, like we've been doing. We had a lot of success with it this year up until just very recently, where that pattern did not materialize. But overall, it's still a pretty good window to keep yourself into. So we'll do that continuing going forward, and follow this pattern and see if we can maybe squeeze something out for the snow lovers before it ends here. It is possible, but we should be able to handle that on a shorter-term basis. I'm EPAWA meteorologist Bobby Marchus. That is this edition of Weather Weeklies for Sunday, February 18th. Again, next week is going to be up in the air. I'll let you know on social media if that's still taking place, but if not, it was great spending my time with you here on Sunday. And thank you for all of you for watching and following throughout this season. Take care.